All right, let's zoom into the nucleus of the atom. And to do this, it's going to help if we have some shared vocabulary. First of all, a review. The nucleus is right here in the center of the atom, and it contains the most of the mass of the atom by far. Okay, and so this is where the protons and the neutrons are located. It's extremely tiny compared to the rest of the sides of the atom, and so even this model shows it to be, bigger than it would really be compared to the size of the electrons in those rings. But in order to be able to see the atom, the model does a good job. And so you can see these neutrons shown in green, the protons shown in red, and we know that protons have a positive charge, neutrons are neutral, they have no charge, and so the charge of our nucleus is positive. And then we have these electrons buzzing around the outside. And here what you see is the planetary model of the atom, and so the electrons are in rings like planets orbiting the sun. Here's our shared vocab that we want to use. We have nucleons, nuclide, and we want to be able to distinguish between the two. And so nucleons are the specific protons and neutrons. And so a proton is a nucleon, and a neutron is a nucleon. When we use the term nuclide, we are referring to the composition of a specific nucleus. Okay, and so you might talk about a nuclide that has 30 nucleons, and 15 of those are protons, and 15 of those are neutrons. Okay, and so we're just talking about a specific nucleus when we say nuclide. And so we have this question to kind of see if we can use our vocabulary correctly in a sentence. And it says, if a nuclide has 45 nucleons, can you determine what element it is? And so go ahead and pause and think about that. We know that it has 45 nucleons. Do we know what element it would be? Well, the answer to that is no. You can't know for sure. You could make a guess. You know that there's always, usually roughly the same amount of protons and neutrons. So you might say, well, what if 22 of those are protons and 23 of those nucleons are neutrons? Well, let me look at my periodic table. I'm seeing 22 is my titanium. But then couldn't 21 of them be protons and 24 of them be neutrons, in which case it would be, looks like calcium. And so no, you can't determine what element it would be just based on that information. So to review, this particular nuclide has 6 nucleons. 3 of those nucleons are protons. 3 of those nucleons are neutrons. All right, let's get some practice here. We're going to try to model the nucleus with magnets. Okay, and so the different colored magnets are going to represent our different nucleons. So we'll have one color be protons and one color be neutrons. Okay, let's read our intro here. It says, you're made of atoms. Atoms are tiny building blocks of matter that come in different types, which are elements, and make up all objects you know: pencils, cars, the earth, the sun. Atoms consist of a nucleus of protons and neutrons surrounded by a cloud of electrons. And then we've got a little question here to help us with our comprehension. So we see a model here off to the right. And so go ahead and start by answering these two questions. What features of the atom does this model show well? Think about the location of the different subatomic particles. Think about what you know about the charge of subatomic particles, the size of the different features of the element, those electrons, the nucleus as a whole. Think about where the electrons are and what we've learned about that. And then question 2 says, what features of the atom are not really clearly shown by the model? What are the things that it's not trying to show very well or very accurately? We know that models aren't direct representations of reality, and so what are some of the weaknesses of this model, or was it not trying to show well?